All right, so class, we're gonna jump into example number 2. We're gonna find the horizontal asymptote, the vertical asymptote, and any holes in the graph. We haven't talked about holes yet, but we'll talk about this in this example. All right, so let's jump in with the horizontal asymptote, and it's also known as the end behavior of the function. And it's the end behavior because we're trying to figure out what is going on as x approaches infinity and what's going on as x approaches negative infinity, as you guys can see in my discovery example, in my intro video that I did for this section. So pretty much what we want to know is what's going on the function as x approaches positive infinity. So let's go ahead and do that. Let's take the limit as x approaches infinity, right? And behavior, right? If you guys think about it, and behavior, it happens over there and over there, right? Negative infinity and positive infinity. Okay, so let's pretend that we're plugging in infinity, right? So if you plug in infinity here, let's see, where's my, if you plug in, let's say you plug in infinity minus 3 is still going to be positive infinity, right? Because infinity is so big. And you still got to square it, right? Well, the square of infinity is still going to be infinity, right? Infinity. So pretty much what we have here is 2 over infinity. Well, in other words, 2 over a huge number, right? Which means that this is going to be 0. With the same argument, we'll do that for x approaches negative infinity. But in this case, we're approaching negative infinity. So it's the same idea. Now you have negative infinity minus 3 gives you negative infinity, right? Negative infinity minus 3 is negative infinity. Negative infinity square gives you positive infinity. And so now you have 2 over positive infinity, which is the same thing that we had before, which is 0. Remember that 2 over a huge number is going to be 0, right? You guys remember that? Because you're dividing a number by a huge number, right? Think about it as 2 over 1 trillion. That's going to be like 0.000000000000000 what, 5 or something. I don't know, right? Like, it's going to be a very small number. So there you go, right? We have found that these are approaching the same value, so therefore there's no so there is a horizontal asymptote, and the horizontal asymptote happens to be that value, right? Y equals 0. So think about it, this is going to be giving you your horizontal asymptote. There you go, right? Let's try the vertical asymptote. The vertical asymptote is, we're going to approach it in a different way. The only way that this is going to be undefined, we're just trying to find where is this vertical asymptote. To find the location of this vertical asymptote, what we need to do is take the denominator, determine whenever this is equal to 0. So what x values makes the denominator be 0? By doing that, we're going to find where the function is undefined. So what else of x will make the denominator be 0, which makes the whole function undefined. So we can think about that if we take the square root on both sides of the equation, or we can think about it as that only way that this whole thing will be 0, is whenever the inside of this square is 0, right? Because this number, in order for us to square a number and to get a 0, that means that this needed to be a 0. We have gone over this a few times, right? And then we can add 3 on both sides of the equation, and so we get x equals 3. So that's your vertical asymptote. And there you go, right? So we found our horizontal asymptote, our vertical asymptote. Now we have to find the holes. So typically a hole will happen, a hole will happen whenever you have an undefined value on the denominator that was canceled on the numerator. In this case, there wasn't, right? There was no cancellation of a zero with the zero on the numerator. Like there was no cancellation of a factor. We do have an examples of that in the future in the next video, so just look over those later on. So in this case, there's no holes in the function. So what happens is that if that hole happens to be canceled, right? That factor happens to be canceled, that would make the function be undefined.